Last lecture, I explained memory networks, which is a very important network, but it was not end-to-end. This lecture, I'm going to be presenting this amazing article again in 2015, just like the memory network, but it is end-to-end. The architecture is a form of memory network, but unlike the model in that work, it is trained end-to-end and hence requires significantly less supervision. When I think about end-to-end in our brain, I think our brain is not end-to-end. It has lots of regions and they are interconnected. Each region is for a different reason. So they are doing something, it's like distributed learning rather than just end-to-end. And for example, the error from here is not, I don't think it is propagated to all regions of the brain. So the architecture is a form of memory network, just like the previous lecture, but unlike the model in that work, it is trained end-to-end and hence requires significantly less supervision during training. But this is good. It needs less supervision. Because if it is not end-to-end, then at each stage, you need to have lots of training data, input, output. And so it's not tractable. It's very hard to find those data sets. It becomes huge. But if we just do it end-to-end, then if we just know what are the inputs and outputs, and we are not interested in the inside. And of course, it has problems that it is not explainable, it cannot debug it, it's not interpretable, and many other things in AI. So what is the idea of this paper? Our model takes a discrete set of inputs that are to be stored in the memory. For example, those sentences that in that data set that, for example, Bob left something in the kitchen. Then he went to the office and those kind of things. But each of them is sent to the memory. And we have a query, for example, where is the car now? Or where is the milk now? Or those kind of queries. And the answer is, for example, either it is in kitchen or it is in my friend's house, or any other thing. So we start by describing our model in single layer. For single layer, so we are given some inputs, x1, xi, those sentences that should be stored in a memory. They are converted into, the entire set is converted into memory, m1 to mi. But each one has dimension d. On the other hand, we have U as well. So the query is embedded and we have internal state. So this is your query that is embedded. So we call it embedded query. We have embedded query, we have our memory, and now we understand how to attend to particular memory. For example, attend to memory I with probability pi. And it's a kind of soft attention. Output memory, they have an interesting idea that they just use another embedding C instead of just giving XI. They give it another embedding CI because it's another source of learning, another source of that we can learn by these weights. So the response vector from the output is then the sum over, because we know the probability of each of those memories and the corresponding CIs, then we have the output. But the output is not everything. We need the output, we add it with the U, which is the embedded question, and then what we give, if you multiply by W and goes through softmax, we have the answer. So this is just for single layer like this, just a single layer. But you stack them upon each other, then you have a multi-layer approach. So this is the multi-layer approach. At each stage, UK plus output is UK plus 1. And this is how you do. We explore two types of weight trying within the model. The first one is adjacent. The output embedding of one layer is input embedding for the above. Or layer-wise, like recurrent neural networks that we say input and output are the same across different layers. So a 3-layer version is shown in this figure. And these are synthetic question answering, as I've explained in the previous lecture for reasoning. It's a very good data set, but also it's very simple. Life is not as simple as this. So it is good for elementary and simple algorithms. So we have hop 1, hop 2, and hop 3. We know how to attend to these different memories. And these are visualization of those attention weights. Those after softmax, you see there is a attention. So these are the visualization of that.